Hello and welcome to Sean White's Solar and Energy Storage Podcast. This podcast is a reading from the National Electrical Code, Article 690, Photovoltaic Systems. Every 3 years, a new version of the NEC comes out, and I choose to read and post it. And this year, I have decided to pod post it. I have also directed my students in my HeatSpring 40-hour advanced PV class here, since it is easier to listen from a podcast than a downloadable MP4. To find out more about my HeatSpring class and everything else, go to SolarSean.com. If you are not a technical solar person, you will find listening to this podcast exceptional for insomnia and becoming familiar with big solar words. When I first read the NEC, I had no idea what it meant, but it did become familiar and was a step towards enlightenment. That's right, ladies and gentlemen. The 2020 NEC is out and about, and welcome to Radio Station 690. First, what we're going to do is we're just going to read part one of the NEC Article 690 from the 2020 NEC, and I'm going to try to use my voice inflections to make this as interesting as possible. However, reading the NEC could put a lot of people to sleep, so let's see what we can do. We're going for Radio Station 690, Part 1 General. The National Electrical Code, Article 690, Solar Photovoltaic PV Systems. 690.1 Scope. This article applies to solar PV systems other than those covered by Article 691, including the array circuits, inverters, and controllers for such systems. The systems covered by this article include those interactive with other electric power production sources or standalone or both. These PV systems may have AC or DC output for utilization. 690.1 Scope Informational Note Number 1. Informational Note Figure 690.1a and Informational Note Figure 690.1b. So there's some pictures there we're going to look at. And then there's Informational Note Number 2. Article 691 covers installation of large-scale PV electric supply stations. And we cannot audio send you a picture, but Informational Note Figure 690.1a has some different components. We're showing a module and an array, and there's just different diagrams, including an interactive system, an AC module system, a DC coupled multi-mode system, an AC coupled multi-mode system, and a standalone system. Now we're looking at 690.2 definitions. The definitions in this section shall apply only within this article. First definition, AC module system. An assembly of AC modules, wiring methods, materials, and subassemblies that are evaluated, identified, and defined as a system. Alternating current AC module, alternating current photovoltaic module. A complete environmentally protected unit consisting of solar cells, inverter, and other components designed to produce AC power. And now we will define array. A mechanically and electrically integrated grouping of modules with support structure, including any attached system components such as inverters or DC to DC converters and attached associated wiring. Defining bipolar circuit. A DC circuit that is comprised of two monopole circuits, each having an opposite polarity connected to a common reference point. Next definition, DC to DC converter output circuit. The DC circuit conductors connected to the output of a DC combiner for DC to DC converter source circuits. And the next definition is DC to DC converter source circuit. Circuits between DC to DC converters and from DC to DC converters to the common connection points of the DC system. Definition for direct current DC combiner. An enclosure that includes devices used to connect two or more PV system DC circuits in parallel. Electronic power converter definition. A device that uses power electronics to convert one form of electrical power into another form of electrical power. Informational note for electronic power converter. Examples of electronic power converters include, but are not limited to, inverters, DC to DC converters, and electronic charge controllers. These devices have limited current capabilities based on the device ratings at continuous rated power. Now we will define grounded, functionally grounded. A system that has an electrical ground reference for operational purposes that is not solidly grounded. Informational note for grounded functionally. A functionally grounded system is often connected to ground through an electronic means internal to an inverter or charge controller that provides ground fault protection. Examples of operational purposes for functionally grounded systems include ground fault detection and performance-related issues for some power sources. Module definition. A complete, environmentally protected unit consisting of solar cells and other components designed to produce DC power. Monopole circuit definition. An electrical subset of a PV system that has two conductors in the output circuit, one positive and one negative. PV output circuit definition. The DC circuit conductors from two or more connected PV source circuits to their point of termination. PV source circuit definition. The DC circuit conductors between modules and from modules to DC combiners, electronic power converters, or a DC PV system disconnecting means. PV system DC circuit definition. Any DC conductor in PV source circuits, PV output circuits, DC to DC converter source circuits, and DC to DC converter output circuits. Solar cell definition. The basic device that generates electricity when exposed to light. Now, 690.4 General Requirements. 690.4a Photovoltaic Systems. Photovoltaic systems shall be permitted to supply a building or other structure in addition to any other electrical supply systems. 690.4b Equipment. Inverters, motor generators, PV modules, AC modules, and AC module systems, DC combiners, DC to DC converters, rapid shutdown equipment, DC circuit controllers, and charge controllers intended for use in PV systems shall be listed or be evaluated for the application and have a field label applied. 690.4c Qualified Personnel. The installation of equipment and associated wiring and interconnections shall be performed only by qualified persons. Informational note for 690.4c Qualified Persons. See Article 100 for the definition of qualified persons. 690.4d Multiple PV Systems. Multiple PV systems shall be permitted to be installed in or on a single building or structure. Where the PV systems are remotely located from each other, a directory in accordance with 705.10 shall be provided at each PV system disconnecting means. 690.4e Locations not permitted. PV system equipment and disconnecting means shall not be installed in bathrooms. 690.4f Electronic power converters mounted in not readily accessible locations. Electronic power converters and their associated devices shall be permitted to be mounted on roofs or other exterior areas that are not readily accessible. Disconnecting means shall be installed in accordance with 690.15. 690.6 Alternating current AC modules and systems. 690.6a Photovoltaic source circuits. The requirements of Article 690 pertaining to PV source circuits shall not apply to AC modules or AC module systems. The PV source circuit conductors and inverters shall be considered as internal components of an AC module or AC module system. 690.6b Output circuit. The output of an AC module or AC module system shall be considered to be an inverter output circuit. And that brings us to the end of Part 1, Article 690. Radio 690, National Electrical Code. Article 690, Part 2, Circuit Requirements. 690.7 Maximum Voltage. The maximum voltage of PV system DC circuits shall be the highest voltage between any two conductors of a circuit or any conductor and ground. The maximum voltage shall be used to determine the voltage and voltage to ground of circuits in the application of this code. Maximum voltage shall be used for conductors, cables, equipment, and working space and other applications where voltage limits and ratings are used. PV system DC circuits on or in buildings shall be permitted to have a maximum voltage no greater than 1,000 volts. PV system DC circuits on or in 1 and 2 family dwellings shall be permitted to have a maximum voltage no greater than 600 volts. Where not located on or in buildings, listed PV DC equipment rated at a maximum voltage no greater than 1,500 volts shall not be required to comply with Parts 2 and 3 of Article 490. 690.7a Photovoltaic source and output circuits. In a DC PV source circuit or output circuit, the maximum PV system voltage for that circuit shall be calculated in accordance with one of the following methods. 1. The sum of the PV module rated open circuit voltage of the series connected modules corrected for the lowest expected ambient temperature using the open circuit voltage temperature coefficients in accordance with the instructions included in the listing or labeling of the module. 2. For crystalline and multicrystalline silicon modules, the sum of the PV module rated open circuit voltage of the series connected modules corrected for the lowest expected ambient temperature using the correction factors provided in Table 690.7a. 3. For PV systems with an inverter generating capacity of 100 kilowatts or greater, a documented and stamped PV system design using an industry standard method. Maximum voltage calculation provided by a licensed professional electrical engineer. Informational note number 1 of 690.7a. One source for lowest expected ambient temperature design data for various locations is the chapter titled Extreme Annual Mean Minimum Design Dry Bulb Temperature, found in the ASHRAE Handbook Fundamentals 2017. These temperature data can be used to calculate maximum voltage. And now we're looking at 690.7a Photovoltaic source and output circuits. Informational note number 2. One industry standard method for calculating maximum voltage of a PV system is published by Sandia National Laboratories. Reference SAN 2004-3535 Photovoltaic Array Performance Model. Then we have Table 690.7a Voltage Correction Factors for crystalline and multicrystalline silicon solar modules. And what we're going to have in this table is it has the ambient temperature, the correction factor, and then once again the ambient temperature in degrees Fahrenheit. Typically, we go by Celsius. And just for instance, I'm going to pick one of these off. If the ambient temperature in degrees Celsius is between -1 and -5, you use a 1.12 correction factor. That would be a 12% increase in voltage. 690.7b, DC to DC converter source and output circuits. In a DC to DC converter source and output circuit, the maximum voltage shall be calculated in accordance with 690.7b1 or b2. And here is 690.7b1, single DC to DC converter. For circuits connected to the output of a single DC to DC converter, the maximum voltage shall be determined in accordance with the instructions included in the listing or labeling of the DC to DC converter. If the instructions do not provide a method to determine the maximum voltage shall be the maximum rated voltage output of the DC to DC converter. 690.7b2, two or more series connected DC to DC converters. For circuits connected to the output of two or more series connected DC to DC converters, the maximum voltage shall be determined in accordance with the instructions included in the listing or labeling of the DC to DC converter. If the instructions do not provide a method to determine the maximum voltage shall be the sum of the maximum rated voltage output of the DC to DC converters in series. 690.7c, bipolar source and output circuits. For monopole subarrays in bipolar systems, the maximum voltage shall be the highest voltage between the monopole subarray circuit conductors where one conductor of the monopole subarray circuit is connected to the functionally grounded reference. To prevent overvoltage in the event of a ground fault or arc fault, the monopole subarray circuits shall be isolated from ground. 690.8, circuit sizing and current. 690.8a, calculation of maximum circuit current. The maximum circuit current for the specific circuit shall be calculated in accordance with one of the methods in 690.8a1 or a2. 690.8a1, PV system circuits. The maximum current shall be calculated in accordance with 690.8a1a through a1e. And here is 690.8a1a. Photovoltaic source circuit currents. The maximum current shall be calculated in either of the following. And 690.8a1a1. The maximum current shall be the sum of the short circuit current ratings of the PV modules connected in parallel multiplied by 125%. 690.8a1a2. For PV systems with an inverter generating capacity of 100 kilowatts or greater, a documented and stamped PV system design using an industry standard method, maximum current calculation provided by a licensed professional electrical engineer shall be permitted. The calculated maximum current value shall be based on the highest 3-hour current average resulting from the simulated local irradiance on a PV array accounting for the elevation and orientation. The current value used by this method shall not be less than 70% of the value calculated using 690.8a1a1. And now we have the 690.8a1 informational note. One industry standard method for calculating maximum current of a PV system is available from Sandia National Laboratories, reference SAN 2004-3535, Photovoltaic Array Performance Model. This model is used by the System Advisor Model Simulation Program provided by the National Renewable Energy Laboratories. 690.8a1b, photovoltaic output circuits. The maximum current shall be the sum of the parallel source circuit maximum currents as calculated in 690.8A1A. 690.8A1C, DC to DC converter source circuit current. The maximum current shall be the DC to DC converter continuous output current rating. 690.8A1D, DC to DC converter output circuit current. The maximum current shall be the sum of the parallel connected DC to DC converter source circuits as calculated in 690.8A1C. 690.8A1E, inverter output circuit current. The maximum current shall be the inverter continuous output current rating. 690.8A2, circuits connected to the input of electronic power converters. Where a circuit is protected with an overcurrent device not exceeding the conductor ampacity, the maximum current shall be permitted to be the rated input current of the electronic power converter input to which it is connected. 690.8b, conductor ampacity. Circuit conductors shall be sized to carry not less than the larger ampacity calculated in accordance with 690.8B1 or B2. 690.8B1, without adjustment and correction factors. The maximum currents calculated in 690.8A multiplied by 125% without adjustment or correction factors. And then we have the 690.8B1 exception. Circuits containing an assembly together with its overcurrent devices that is listed for continuous operation at 100% of its rating shall be permitted to be used at 100% of its rating. 690.8B2, with adjustment and correction factors. The maximum currents calculated in 690.8A with adjustment and correction factors. 690.8C, systems with multiple direct current voltages. For a PV power source that has multiple output circuit voltages and employs a common return conductor, the ampacity of the common return conductor shall not be less than the sum of the ampere rating of the overcurrent devices of the individual output circuits. 690.8D, sizing of module interconnection conductors. Where a single overcurrent device is used to protect a set of two or more parallel connected module circuits, the ampacity of each of the module interconnection conductors shall not be less than the sum of the rating of the single overcurrent device plus 125% of short circuit current from the other parallel connected modules. 690.9, overcurrent protection. 690.9A, circuits and equipment. PV system DC circuits and inverter output conductors and equipment shall be protected against overcurrent. Circuits sized in accordance with 690.8A2 are required to be protected against overcurrent with overcurrent protective devices. Each circuit shall be protected from overcurrent in accordance with 690.9A1, A2, or A3. 690.9A1, circuits where overcurrent protection not required. Overcurrent protective devices shall not be required where both of the following conditions are met. 690.9A11, the conductors have sufficient ampacity for the maximum circuit current. 690.9A12, the currents from all sources do not exceed the maximum overcurrent protective device rating specified for the PV module or electronic power converter. 690.9A2, circuits where overcurrent protection is required on one end. A circuit conductor connected at one end to a current limited supply, where the conductor is rated for the maximum circuit current from that supply, and also connected to sources having an available maximum circuit current greater than the ampacity of the conductor, shall be protected from overcurrent at the point of connection to the higher current source. 690.9A2 Informational Note. Photovoltaic system DC circuits with electronic power converter outputs powered by these circuits are current limited and in some cases do not need overcurrent protection. Where these circuits are connected to the higher current sources, such as parallel connected PV system DC circuits, energy storage systems, or a utility service, the overcurrent device is often installed at the higher current source end of the circuit conductor. 690.9A3 Other circuits. Circuits that do not comply with 690.9A1 or A2 shall be protected with one of the following methods. 690.9A3 1 through 4. And so now we're at 690.9A3 Conductors not greater than 3 meters 10 feet in length and not in buildings protected from overcurrent on one end. 690.9A32. Conductors not greater than 3 meters 10 feet in length and in buildings protected from overcurrent on one end and in raceway or metal-clad cable. 690.9A33. Conductors protected from overcurrent on both ends. 690.9A34. Conductors not installed on or in buildings are permitted to be protected from overcurrent on one end of a circuit where the circuit complies with all of the following conditions. And we have A through D following conditions. 690.9A34A. The conductors are installed in metal raceways or metal-clad cables, or installed in enclosed metal cable trays or underground, or where directly entering pad-mounted enclosures. 690.9A34B. The conductors for each circuit terminate on one end at a single circuit breaker or a single set of fuses that limit the current to the ampacities of the conductors. 690.9A34C. The overcurrent device for the conductors is an integral part of a disconnecting means or shall be located within 3 meters 10 feet of conductor length of the disconnecting means. 690.9A34D. The disconnecting means for the conductors is installed outside of a building or at a readily accessible location nearest the point of entrance of the conductors inside of a building, including installations complying with 230.6. 690.9B Device ratings. Overcurrent devices used in PV system DC circuits shall be listed for use in PV systems. Electronic devices that are listed to prevent backfeed current in PV system DC circuits shall be permitted to prevent overcurrent of conductors on the PV array side of the device. Overcurrent devices, where required, shall be rated in accordance with one of the following and permitted to be rounded up to the next higher standard size accordance with 240.4b. And we have 690.9b1, not less than 125% of the maximum currents calculated in 690.8a or 690.9b2, an assembly together with its overcurrent devices that is listed for continuous operation at 100% of its rating shall be permitted to be used at 100% of its rating. 690.9b Informational Note. Some electronic devices prevent backfeed current, which in some cases is the only source of overcurrent in PV system DC circuits. 690.9c, source and output circuits. A single overcurrent protective device, where required, shall be permitted to protect the PV modules, DC to DC converters, and conductors of each source circuit or the conductors of each output circuit. Where single overcurrent protection devices are used to protect source or output circuits, all overcurrent devices shall be placed in the same polarity for all the circuits within a PV system. The overcurrent devices shall be accessible, but shall not be required to be readily accessible. Informational note for 690.9c. Due to improved ground fault protection required in PV systems by 690.41b, a single overcurrent protective device in either the positive or negative conductors of a PV system, in combination with this ground fault protection, provides adequate overcurrent protection. 690.9d, power transformers. Overcurrent protection for a transformer with a source or sources on each side shall be provided in accordance with 450.3 by considering first one side of a transformer, then the other side of the transformer as a primary. 690.9d, exception. A power transformer with a current rating on the side connected toward the interactive inverter output, not less than the rated continuous output current of the inverter, shall be permitted without overcurrent protection from the inverter. 690.10, standalone systems. The wiring system connected to a standalone system shall be installed in accordance with 710.15. 690.11, arc fault circuit protection, direct current. Photovoltaic systems with PV system DC circuits operating at 80 volts DC or greater between any two conductors shall be protected by a listed PV arc fault circuit interrupter or other system components listed to provide equivalent protection. The system shall detect and interrupt arcing faults resulting from a failure in the intended continuity of a conductor, connection, module, or other system component in the PV system DC circuits. Informational note for 690.11. Annex A includes the reference for the photovoltaic DC arc fault circuit protection product standard. 690.11, exception. Exception for PV systems not installed on or in buildings, PV output circuits, and DC to DC converter output circuits that are installed in metallic raceways or metal-clad cables, or installed in enclosed metallic cable trays, or that are underground, shall be permitted without arc fault circuit protection. Detached structures whose sole purpose is to house PV system equipment shall not be considered buildings according to this exception. 690.12, rapid shutdown of PV systems on buildings. PV system circuits installed on or in buildings shall include a rapid shutdown function to reduce shock hazard for firefighters in accordance with 690.12a through D. 690.12 exception. Ground-mounted PV system circuits that enter buildings of which the sole purpose is to house PV system equipment shall not be required to comply with 690.12. 690.12a, controlled conductors. Requirements for controlled conductors shall apply to the following, 1 and 2. 690.12a1, PV system DC circuits. 690.12a2, inverter output circuits originating from inverters located within the array boundary. 690.12a, informational note. The rapid shutdown function reduces the risk of electric shock that DC circuits in a PV system could pose for firefighters. The AC output conductors from the PV systems that include inverters will either be de-energized after shutdown initiation or will remain energized by other sources such as a utility service. To prevent PV arrays with attached inverters from having energized AC conductors within the PV array, those circuits are also specifically controlled after shutdown initiation. 690.12b Controlled Limits. The use of the term array boundary in this section is defined as 305 millimeters, 1 foot, from the array in all directions. Controlled conductors outside of the array boundary shall comply with 690.12b1, and inside of the array boundary shall comply with 690.12b2. 690.12b1 outside the array boundary. Controlled conductors located outside the boundary or more than 1 meter, 3 feet from the point of entry inside a building shall be limited to not more than 30 volts within 30 seconds of rapid shutdown initiation. Voltage shall be measured between any two conductors and between any conductor and ground. 690.12b2 inside the array boundary. The PV system shall comply with one of the following. 1, 2, 3. 690.12b21. A PV hazard control system listed for the purpose shall be installed in accordance with the instructions, including with the listing or field labeling. Where a hazard control system requires initiation to transition to a controlled state, the rapid shutdown initiation device required in 690.12c shall perform this initiation. And then we have 690.12b21 informational note. A listed or field labeled hazard PV control system is comprised of either an individual piece of equipment that fulfills necessary functions or multiple pieces of equipment coordinated to perform the functions described. In the installation instructions to reduce the risk of electric shock hazard within a damaged PV array for firefighters. See UL 3741 Photovoltaic Hazard Control. Then we have 690.12b22. Controlled conductors located inside the boundary shall be limited to not more than 80 volts within 30 seconds of rapid shutdown initiation. Voltage shall be measured between any two conductors and between any conductor and ground. 690.12b23. PV arrays shall have no exposed wiring methods or conductive parts and be installed more than 2.5 meters, 8 feet from exposed, grounded, conductive parts or ground. 690.12c Initiation Device. The initiation devices shall initiate the rapid shutdown function of the PV system. The device's off position shall indicate that the rapid shutdown function has been initiated for all PV systems connected to that device. For one family and two family dwellings, an initiation device or devices shall be located at a readily accessible location outside the building. For a single PV system, the rapid shutdown initiation shall occur by the operation of any single initiation device. Devices shall consist of at least one or more of the following. And there's three things of the following, and that is 690.12c1, service disconnecting means. 690.12c2, PV system disconnecting means. 690.12c3, readily accessible switch that plainly indicates whether it is in the off or on position. Informational note. Examples of where an initiation device complies with 690.12c3 would be used is where a PV system is connected to an optional standby or standalone system. And then we go on for more of 690.12c. Where multiple PV systems are installed with rapid shutdown functions on a single service, the initiation device or devices shall consist of not more than 6 switches or 6 sets of circuit breakers, or a combination of not more than 6 switches and sets of circuit breakers mounted in a single enclosure, or in a group of separate enclosures. These initiation devices shall initiate the rapid shutdown of all PV systems with rapid shutdown functions on that service. 690.12d Equipment. Equipment that performs the rapid shutdown functions other than initiation devices, such as listed disconnect switches, circuit breakers, or control switches, shall be listed for providing rapid shutdown protection. And that's right, that's it, folks. That brings us to the end of Part 2, Article 690, Photovoltaic Systems and the 2020 National Electrical Code. Radio 690, 690 Part 3, Disconnecting Means. 690.13, Photovoltaic System Disconnecting Means. Means shall be provided to disconnect the PV system from all wiring systems, including power systems, energy storage systems, and utilization equipment, and its associated premises wiring. 690.13a, Location. The PV system disconnecting means shall be installed at a readily accessible location. Where disconnecting means of systems above 30 volts are readily accessible to unqualified persons, any enclosure door or hinge cover that exposes live parts when open shall be locked or require a tool to open. Informational note: PV systems installed in accordance with 690.12 address the concerns related to energized conductors entering a building. 690.13b, Marking. Each PV system disconnecting means shall plainly indicate whether in the open, off, or closed on position and be permanently marked PV system disconnect or equivalent. Additional markings shall be permitted based upon the specific system configuration. For PV system disconnecting means where the line and load terminals may be energized in the open position, the device shall be marked with the following words or equivalent. Warning: electric shock hazard. Terminals on the line and load sides may be energized in the open position. The warning signs or labels shall comply with 110.21b. 690.13c, Maximum number of disconnects. Each PV system disconnecting means shall consist of not more than 6 switches or 6 sets of circuit breakers, or a combination of not more than 6 switches and sets of circuit breakers mounted in a single enclosure or in a group of separate enclosures. A single PV system disconnecting means shall be permitted for the combined AC output of one or more inverters or AC modules in an interactive system. Informational note: this requirement does not limit the number of PV systems connected to a service as permitted in 690.4d. This requirement allows up to 6 disconnecting means to disconnect a single PV system. For PV systems where all power is converted through interactive inverters, a dedicated circuit breaker in 705.12b1 is an example of a single PV system disconnecting means. 690.13d, Ratings. The PV system disconnecting means shall have the ratings sufficient for the maximum circuit current, available fault current, and voltage that is available at the terminals of the PV system disconnect. 690.13e, Type of disconnect. The PV system disconnecting means shall simultaneously disconnect the PV system conductors that are not solidly grounded from all conductors or other wiring systems. The PV system disconnecting means or its remote operating device or the enclosure providing access to the disconnecting means shall be capable of being locked in accordance with 110.25. The PV system disconnecting means shall be one of the following. 1. A manual operable switch or circuit breaker. 2. A connector meeting the requirements of 690.33D1 or D3. 3. A pull-out switch with the required interrupting rating. 4. A remote-controlled switch or circuit breaker that is operable locally and opens automatically when control power is interrupted. 5. A device listed or approved for the intended application. Informational note. Circuit breakers marked line and load may not be suitable for backfeed or reverse current. 690.15 Disconnecting means for isolating photovoltaic equipment. Disconnecting means of the type required in 690.15d shall be provided to disconnect AC PV modules, fuses, DC to DC converters, inverters, and charge controllers from all conductors that are not solidly grounded. 690.15a Location. Isolating devices or equipment disconnecting means shall be installed in circuits connected to equipment at a location within the equipment or within sight and within 3 meters 10 feet of the equipment. An equipment disconnecting means shall be permitted to be remote from the equipment where the equipment disconnecting means can be remotely operated within 3 meters 10 feet of the equipment. Where disconnecting means of equipment operating above 30 volts are readily accessible to unqualified persons, any enclosure door or hinged cover that exposes live parts when open shall be locked or require a tool to open. 690.15b Isolating device. An isolating device shall not be required to have an interrupting rating. Where an isolating device is not rated for interrupting the circuit current, it shall be marked, "Do not disconnect under load," or "Not for current interrupting." An isolating device shall not be required to simultaneously disconnect all current-carrying conductors of a circuit. The isolating device shall be one of the following. 1. A mating conductor meeting the requirements of 690.33 and listed and identified for use with specific equipment. 2. A finger-safe fuse holder. 3. An isolating device that requires a tool to place the device in the open-off position. 4. An isolating device listed for the intended application. 690.15c Equipment disconnecting means. Equipment disconnecting means shall have ratings sufficient for the maximum circuit current, available fault current, and voltage that is available at the terminals. Equipment disconnecting means shall simultaneously disconnect all current-carrying conductors that are not solidly grounded to the circuit which is connected. Equipment disconnecting means shall be externally operable without exposing the operator to contact with energized parts and shall indicate whether in the open, off, or closed on position. Where not within sight or not within 3 meters, 10 feet of the equipment, the disconnecting means or its remote operating device or the enclosure providing access to the disconnecting means shall be capable of being locked in accordance with 110.25. Equipment disconnecting means, where used, shall be one of the types in 690.13E1 through E5. Equipment disconnecting means, other than those complying with 690.33, shall be marked in accordance with the warning in 690.13b if the line and load terminals can be energized in the open position. Informational note: a common installation practice is to terminate PV source-side DC conductors in the same manner as the utility source-side AC conductors are generally connected on the line side of a disconnecting means. This practice is more likely to de-energize load side terminals, blades, and fuses when the disconnect is in the open position and no energized sources are connected to the load side of the disconnect. 690.15d type of disconnecting means. Where the disconnects are required to isolate equipment, the disconnecting means shall be one of the following applicable types. 1. An equipment disconnecting means, in accordance with 690.15c, shall be required to isolate DC circuits with a maximum circuit current over 80 amperes. 2. An isolating device in accordance with 690.15b shall be permitted for circuits other than those covered by 690.15d1. Radio 690. 690 Part 4, Wiring Methods and Materials. 690.31, Wiring Methods. 690.31a, Wiring Systems. All raceway and cable wiring methods included in this code, other wiring systems and fittings specifically listed for use in PV arrays, and wiring as part of a listed system shall be permitted. Where wiring devices with integral enclosures are used, sufficient length of cable shall be provided to facilitate replacement. Where PV source and output circuits operating at voltages greater than 30 volts are installed in readily accessible locations, circuit conductors shall be guarded or installed in type MC cable or in raceway. The ampacity of 105C, 221F, and 125C, 257F conductors shall be permitted to be determined by Table 690.31ab. For ambient temperatures greater than 30 C, 86 Fahrenheit, the ampacities of these conductors shall be corrected in accordance with 690.31aa. Informational note: C. 110.14c for conductor temperature limitations due to termination provisions. 690.31b, Identification and Grouping. PV system DC circuits and Class 1 remote-controlled signaling and power-limited circuits of a PV system shall be permitted to occupy the same equipment wiring enclosure, cable, or raceway. PV system DC circuits shall not occupy the same equipment wiring enclosure, cable, or raceway as other non-PV systems or inverter output circuits, unless the PV system DC circuits are separated from other circuits by a barrier or partition. PV system circuit conductors shall be identified and grouped as required by 690.31b1 and b2. Exception: PV system DC circuits utilizing multi-conductor jacketed cables or metal-clad cable assemblies or listed wiring harnesses identified for the application shall be permitted to occupy the same wiring method as inverter output circuits and other non-PV systems. All conductors, harnesses, or assemblies shall have an insulation rating equal to at least the maximum circuit voltage applied to any conductor within the enclosure, cable, or raceway. 690.31b1 Identification. PV system DC circuit conductors shall be identified at all termination, connection, and splice points by color coding, marking tape, tagging, or other approved means. Conductors relying on other than color coding for polarity identification shall be identified by an approved permanent marking means such as labeling, sleeving, or shrink tubing that is suitable for the conductor size. The permanent marking means for non-solidly grounded positive conductors shall include imprinted plus signs, plus, or the word positive or POS, durably marked on the insulation of a color other than green, white, or gray. The permanent marking means for non-solidly grounded negative conductors shall include imprinted negative signs, negative, or the word negative, or NEG, durably marked on insulation of a color other than green, white, gray, or red. Only solidly grounded PV system DC circuit conductors shall be marked in accordance with 200.6. Exception: where the identification of the conductors is evident by spacing or arrangement, further identification shall not be required. 690.31b2 Grouping: where the conductors of more than one PV system occupy the same junction box or raceway with a removable cover, the PV system conductors of each system shall be grouped separately by cable ties or similar means at least once, and shall then be grouped at intervals not to exceed 1.8 meters, 6 feet. Exception: the requirement for grouping shall not apply if the circuit enters from a cable or raceway unique to the circuit that makes the grouping obvious. 690.31c Cables: type PV wire or cable and type distributed generation DG cable shall be listed. Informational note: CUL 4703 standard for photovoltaic wire for PV wire and UL 3003 distributed generation cables for DG cable. 690.31c1 Single conductor cable: single conductor cable in exposed outdoor locations in PV system DC circuits within the PV array shall be permitted to be one of the following: 1. PV wire or cable. 2. Single conductor cable marked sunlight resistant and type USE-2 and type RHW-2. Exposed cables shall be supported and secured at intervals not to exceed 600 millimeters, 24 inches, by cable ties, straps, hangers, or similar fittings, listed and identified for securement and support in outdoor locations. PV wire or cable shall be permitted in all locations where RHW-2 is permitted. Exception: PV systems meeting the requirements of 691.4 shall be permitted to have support and securement intervals as defined in the engineered design. 690.31c2 Cable tray: single conductor PV wire or cable of all sizes or distributed generation DG cable of all sizes, with or without a cable tray rating, shall be permitted in cable trays installed in outdoor locations, provided that the cables are supported at intervals not to exceed 300 millimeters, 12 inches, and secured at intervals not to exceed 1.4 meters, 4.5 feet. Informational note: PV wire and cable and DG cable have a non-standard outer diameter. Table 1 of Chapter 9 contains the allowable percent of cross-section of conduit and tubing for conductors and cables. 690.31c3 Multi-conductor jacketed cables: where part of a listed PV assembly, multi-conductor jacketed cables shall be installed in accordance with the included instructions. Where not part of a listed assembly or where not otherwise covered in this code, multi-conductor jacketed cables, including DG cable, shall be installed in accordance with the product listing and shall be permitted in PV systems. These cables shall be installed in accordance with the following: 1. In raceways where on or in buildings other than rooftops. 2. Were not in raceways in accordance with the following: A. Marked sunlight resistant in exposed outdoor locations. B. Protected or guarded where subject to physical damage. C. closely follow the surface of support structures. D. Secured at intervals not exceeding 1.8 meters, 6 feet. E. Secured within 600 millimeters, 24 inches of mating connectors or entering enclosures. F. Marked direct burial where buried in earth. 690.31C4. Flexible cords and cables connected to tracking PV arrays. Flexible cords and flexible cables, where connected to moving parts of tracking PV arrays, shall comply with Article 400 and shall be of a type identified as hard service cord or portable power cord. They shall be suitable for extra hard usage, listed for outdoor use, water resistant, and sunlight resistant. Allowable ampacities shall be in accordance with 400.5. Stranded copper PV wire shall be permitted to be connected to moving parts of tracking PV arrays in accordance with a minimum number of strands specified in Table 690.31C4. 690.31C5. Flexible fine-stranded cables. Flexible fine-stranded cables shall be terminated only with terminals, lugs, devices, or connectors in accordance with 110.14. 690.31C6. Small conductor cables. Single conductor cables listed for outdoor use that are sunlight resistant and moisture resistant in sizes 16 AWG and 18 AWG shall be permitted for module interconnections where such cables meet the ampacity requirements of 400.5. Section 310.14 shall be used to determine the cable ampacity adjustment and correction factors. 690.31D. Direct current circuits on or in buildings. Where inside buildings, PV system DC circuits that exceed 30 volts or 8 amperes shall be contained in metal raceways in type MC metal-clad cable that complies with 250.118 or in metal enclosures. Exception: PV hazard control systems installed in accordance with 690.12B21 shall be permitted to be provided with or listed for use with non-metallic enclosures, non-metallic raceways, and cables other than type MC metal-clad cables at the point of penetration of the surface of the building to the PV hazard control actuator. Wiring methods on or in buildings shall comply with the additional installation requirements in 690.31D1 and D2. 690.31D1. Flexible wiring methods. Where flexible metal conduit, FMC, smaller than metric designator 21, trade size 3/4, or type MC cable smaller than 25 millimeter, 1 inch, in diameter containing PV power circuit conductors is insulated across ceilings or floor joists, the raceway or cable shall be protected by substantial guard strips that are at least as high as the raceway or cable. Where run exposed, other than within 1.8 meters, 6 feet, of their connection to the equipment, these wiring methods shall closely follow the building surface or be protected from physical damage by an approved means. 690.31D2. Marking and labeling required. Unless located and arranged so the purpose is evident, the following wiring methods and enclosures that contain PV system DC circuit conductors shall be marked with the wording photovoltaic power source or solar PV DC circuit by means of permanently affixed labels or other approved permanent marking. 1. Exposed raceways, cable trays, and other wiring methods. 2. Covers or enclosures of pull boxes and junction boxes. 3. Conduit bodies in which any of the available conduit openings are unused. The labels or markings shall be visible after installation. All letters shall be capitalized and shall be minimum height of 9.5 millimeters, 3/8 inch, in white on a red background. Labels shall appear on every section of the wiring system that is separated by enclosures, walls, partitions, ceilings, or floors. Spacing between labels or markings, or between a label and a marking, shall not be more than 3 meters, 10 feet. Labels required by this section shall be suitable for the environment where they are installed. 690.31e Bipolar photovoltaic systems. Where the sum, without consideration of polarity, of the voltages of two monopole circuits exceeds the rating of the conductors and connected equipment, monopole circuits in a bipolar PV system shall be physically separated, and the electrical output circuits from each monopole circuit shall be installed in separate raceways until connected to the inverter. The disconnecting means and overcurrent protective devices for each monopole circuit output shall be in separate enclosures. All conductors from each separate monopole circuit shall be routed in the same raceway. Solidly grounded bipolar PV systems shall be clearly marked with a permanent legible warning notice indicating that the disconnection of the grounded conductors may result in overvoltage on the equipment. Exception. Listed switchgear rated for the maximum voltage between circuits and containing a physical barrier separating the disconnecting means for each monopole circuit shall be permitted to be used instead of disconnecting means in separate enclosures. 690.31f Wiring methods and mounting systems. Roof-mounted PV array mounting systems shall be permitted to be held in place with an approved means other than those required by 110.13 and shall utilize wiring methods that allow any expected movement of the array. Informational note: expected movement of unattached PV arrays is often included in structural calculations. 690.32 Component interconnections. Fittings and connectors that are intended to be concealed at the time of on-site assembly, where listed for such use, shall be permitted for on-site interconnection of modules or other array components. Such fittings and connectors shall be equal to the wiring method employed in insulation, temperature rise, and short circuit current rating, and shall be capable of resisting the effects of the environment in which they are used. 690.33 Mating connectors. Mating connectors, other than connectors covered by 690.32, shall comply with 690.33a through D. 690.33a Configuration. The mating connectors shall be polarized and shall have a configuration that is non-interchangeable with receptacles and other electrical systems on the premises. 690.33b Guarding. The mating connectors shall be constructed and insulated so as to guard against intermittent contact with live parts by persons. 690.33c Type. The mating connectors shall be of the latching or locking type. Mating connectors that are readily accessible and that are used in circuits operating at over 30 volts DC or 15 volts AC shall require a tool for opening. Where mating connectors are not the identical type and brand, they shall be listed and identified for intermatability, as described in the manufacturer's instructions. 690.33d Interruption of circuit. Mating connectors shall be one of the following. 1. Rated for interrupting current without hazard to the operator. 2. A type that requires the use of a tool to open and marked do not disconnect under load, or not for current interrupting. 3. Supplied as part of a listed equipment and used in accordance with the instructions provided with the listed connected equipment. Informational note: some listed equipment, such as microinverters, are evaluated to make use of mating connectors as disconnect devices, even though the mating connectors are marked as do not disconnect under load or not for current interrupting. 690.34 Access to boxes. Junction, pull, and outlet boxes located behind modules or panels shall be so installed that the wiring contained in them can be rendered accessible directly or by displacement of a module or panel, secured by removable fasteners and connected by a flexible wiring system. Radio 690, National Electrical Code Part 5, Grounding and Bonding. 690.41 System Grounding. 690.41a PV System Grounding Configurations. One or more of the following system configurations shall be employed. 1. 2-wire PV arrays with one functionally grounded conductor. 2. Bipolar PV arrays according to 690.7c with a functional grounded reference center tap. 3. PV arrays not isolated from the grounded inverter output circuit. 4. Ungrounded PV arrays. 5. Solidly grounded PV arrays as permitted in 690.41b. 6. PV systems that use other methods that accomplish equivalent system protection in accordance with 250.4a with equipment listed and identified for the use. 690.41b Ground Fault Protection. PV system DC circuits that exceed 30 volts or 8 amperes shall be provided with DC ground fault protection, meeting the requirements of 690.41b1 and b2 to reduce fire hazards. Solidly grounded PV source circuits with not more than 2 modules in parallel and not on or in buildings shall be permitted without ground fault protection. Informational note: not all inverters, charge controllers, or DC to DC converters include ground fault protection. Equipment that does not have ground fault protection often includes the following statement in the manual: warning, this unit is not provided with a GFDI device. 690.41b1 Ground fault detection. The ground fault protection device or system shall detect ground faults in the PV system DC circuit conductors, including any functional grounded conductors, and be listed for providing PV ground fault protection. For DC to DC converters not listed as providing ground fault protection, where required, listed ground fault protection equipment identified for the combination of the DC to DC converter and ground fault protection device shall be installed to protect the circuit. Informational note: some DC to DC converters without integral ground fault protection on their input source side can prevent other ground fault protection equipment from properly functioning on portions of PV system DC circuits. 690.41b2 Faulted circuits. The faulted circuits shall be controlled by one of the following methods. 1. The current carrying conductors of the faulted circuit shall be automatically disconnected. 2. The device providing ground fault protection fed by the faulted circuit shall automatically cease to supply power to output circuits and interrupt the faulted PV system DC circuits from the ground reference in a functionally grounded system. 690.41b3 Indication of faults. Ground fault protection equipment shall provide indication of ground faults at a readily accessible location. Informational note. Examples of indication include, but are not limited to, the following: remote indicator light, display, monitor, signal to a monitored alarm system, or receipt of notification by web-based services. 690.42 Point of System Grounding Connection. Systems with a ground fault protective device, in accordance with 690.41b, shall have any current carrying conductor to ground connection made by the ground fault protective device. For solidly grounded PV systems, the DC circuit grounding connection shall be made at any single point on the PV output circuit. 690.43 Equipment Grounding and Bonding. Exposed non-current carrying metal parts of PV module frames, electrical equipment, and conductor enclosures of PV systems shall be connected to an equipment grounding conductor in accordance with 250.134 or 250.136, regardless of voltage. Equipment grounding conductors and devices shall comply with 690.43a through D. 690.43a Photovoltaic module mounting systems and devices. Devices and systems used for mounting PV modules that are also used for bonding module frames shall be listed, labeled, and identified for bonding PV modules. Devices that mount adjacent PV modules shall be permitted to bond adjacent PV modules. 690.43b Equipment secured to grounded metal supports. Devices listed, labeled, and identified for bonding and grounding the metal parts of PV systems shall be permitted to bond the equipment to grounded metal supports. Metallic support structures shall have identified bonding jumpers connected between separate metallic sections, or shall be identified for equipment bonding and shall be connected to the equipment grounding conductor. 690.43c With circuit conductors. Equipment grounding conductors for the PV array and support structure, where installed, shall be contained within the same raceway or cable or otherwise run with PV system conductors where those circuit conductors leave the vicinity of the PV array. 690.43d Bonding for over 250 volts. The bonding requirements contained in 250.97 shall apply only to solidly grounded PV system circuits operating over 250 volts to ground. 690.45 Size of equipment grounding conductors. Equipment grounding conductors for PV system circuits shall be sized in accordance with 250.122. Where no overcurrent protective device is used in the circuit, an assumed overcurrent device rated in accordance with 690.9b shall be used when applying Table 250.122. Increases in equipment grounding conductor size to address voltage drop considerations shall not be required. 690.47 Grounding electrode system. 690.47a Buildings or structures supporting PV system. A building or structure supporting a PV system shall utilize a grounding electrode system installed in accordance with Part 3 of Article 250. PV array equipment grounding conductors shall be connected to a grounding electrode system in accordance with Part 7 of Article 250. This connection shall be in addition to any other equipment grounding conductor requirements in 690.43c. The PV array equipment grounding conductors shall be sized in accordance with 690.45 for specific PV system grounding configurations permitted in 690.41 690.41A, one of the following conditions shall apply. 1. For PV systems that are not solidly grounded, the equipment grounding conductor for the output of the PV system, where connected to associated distribution equipment connected to a grounding electrode system, shall be permitted to be the only connection to ground for the system. 2. For solidly grounded PV systems, as permitted in 690.41A5, the grounded conductor shall be connected to a grounding electrode system by means of a grounding electrode conductor sized in accordance with 250.166. Informational note: most PV systems are functionally grounded systems rather than solidly grounded systems as defined in this code. For functionally grounded PV systems with an interactive inverter output, the AC equipment grounding conductor is connected to associated grounded AC distribution equipment. This connection is most often the connection to ground for ground fault protection and equipment grounding of the PV array. 690.47B, grounding electrodes and grounding electrode conductors. Additional grounding electrodes shall be permitted to be installed in accordance with 250.52 and 250.54. Grounding electrodes shall be permitted to be connected directly to the PV module frames or support structure. A grounding electrode conductor shall be sized according to 250.66. A support structure for a ground-mounted PV array shall be permitted to be considered a grounding electrode if it meets the requirements of 250.52. PV arrays mounted to buildings shall be permitted to use the metal frame of the building if the requirements of 250.68 C2 are met. Radio 690, Article 690 of the National Electrical Code. Readings. Part 6, Marking. 690.51, Modules and AC modules. Modules and AC modules shall be marked in accordance with their listing. 690.53, DC PV circuits. A permanent, readily visible label indicating the highest maximum DC voltage in a PV system, calculated in accordance with 690.7, shall be provided by the installer at one of the following locations. 1. DC PV system disconnecting means. 2. PV system electronic power conversion equipment. 3. Distribution equipment associated with the PV system. 690.54, Interactive System Point of Interconnection. All interactive systems point of interconnection with other sources shall be marked at accessible locations and at the disconnecting means as a power source and with the rated AC output current and the nominal operating AC voltage. 690.55, Photovoltaic systems connected to energy storage systems. The PV system output circuit conductors shall be marked to indicate the polarity where connected to energy storage systems. 690.56, Identification of power sources. 690.56a, Facilities with standalone systems. Plaques or directories shall be installed in accordance with 710.10. 690.56b, Facilities with utility services and photovoltaic systems. Plaques or directories shall be installed in accordance with 705.10 and 712.10 as required. 690.56c, Buildings with rapid shutdown. Buildings with PV systems shall have a permanent label located at each service equipment location to which the PV systems are connected or at an approved readily visible location and shall indicate the location of rapid shutdown initiation devices. The label shall include a simple diagram of a building with a roof and shall include the following words. Solar PV system is equipped with rapid shutdown. Turn rapid shutdown switch to the off position to shut down. PV system and reduce shock hazard in array. The title, Solar PV system is equipped with rapid shutdown, shall utilize capitalized characters with a minimum height of 9.5 millimeters, 3/8 of an inch, in black on yellow background, and the remaining characters shall be capitalized with a minimum height of 4.8 millimeters, 3/16 of an inch, in black on white background. 690.56C1 Buildings with more than one rapid shutdown type. For buildings that have PV systems with more than one rapid shutdown type or PV systems with no rapid shutdown, a detailed plan view diagram of the roof shall be provided showing each different PV system with a dotted line around the areas that remain energized after rapid shutdown is initiated. 690.56C2 Rapid Shutdown Switch. A rapid shutdown switch shall have a label that includes the following wording located on or no more than 1 meter, 3 feet from the switch. Rapid shutdown switch for solar PV system. A label shall be reflective with all letters capitalized and having a minimum height of 9.5 millimeters, 3/8 of an inch, in white on red background. Radio 690 National Electrical Code. Article 690. Parts 7 and 8. Part 7. Connection to other sources. 690.59. Connection to other sources. PV systems connected to other sources shall be installed in accordance with Part 1 and 2 of Article 705 and Article 712. Part 8. Energy Storage Systems. 690.71 General. An energy storage system connected to a PV system shall be installed in accordance with Article 706. 690.72 Self-regulated PV charge control. The PV source circuit shall be considered to comply with the requirements of 706.33 if 1. The PV source circuit is matched to the voltage rating and charge current requirements of the interconnected battery cells, and 2. The maximum charging current multiplied by 1 hour is less than 3% of the rated battery capacity expressed in amp hours or as recommended by the battery manufacturer. And that's it, folks, for the 2020 National Electrical Code. That was Radio 690. I am Sean White. Check me out on SolarSean.com. Thank you for listening to Sean White's Solar and Energy Storage Podcast. You can find out more about Sean White at his links page at SolarSean.com. Thanks for listening. Woo!